mdadm is a Linux utility designed to oversee and control software RAID devices, modernizing the management of RAID setups in Linux distributions by replacing outdated tools like RAID Tools 2 and RAID Tools. Originally developed and copyrighted by Neil Brown from SUSE, mdadm is open-source software distributed under the GNU General Public License. Its name, derived from multiple device, reflects its function of administering and managing MD, multiple device nodes, superseding the previous utility MDCTL. Initially named Mirror Disk, the moniker evolved to represent multiple disk and device management as additional functions were incorporated. In Linux, software RAID configurations encompass various block devices recognized by the kernel, including entire hard drives, e.g., /dev/SDA, and their partitions, e.g., /dev/SDA1. These setups adhere to standard RAID levels such as RAID 0, featuring block-level striping, RAID 1, operating as a mirror, RAID 4, similar to RAID 0 but with an additional device for parity, RAID 5 resembling RAID 4 but with distributed parity across all devices, RAID 6 akin to RAID 5 but with 2 parity segments per stripe, and RAID 10 which combines RAID 1 mirror sets and stripes across them in a RAID 0 fashion. The distinctions between RAID 10 and RAID 0+1 lie in the handling of single drive failures, where RAID 10 maintains normal top-level performance, while RAID 0+1 experiences complete failure of a lower-level stripe. The preference between RAID 10 and RAID 0+1 setups hinges on specific application requirements, such as the availability of spare disks and their activation protocols. Beyond RAID configurations, mdadm supports non-RAID setups like Linear, which concatenates devices into a single MD entity, deprecated since 2021 and eliminated from the Linux kernel by 2023. Multipath, offering failover paths to a single device. Faulty, simulating various disk fault scenarios for testing purposes. And Container, managing a group of devices collectively to construct RAID systems. The original form of names for MD devices is /dev/MD less than n greater than EPOS, where less than n greater than ranges from 0 to 99. More recent kernels now allow names such as /dev/MD/home. Prior to 2.6.x kernels, only non-partitionable arrays without the option for partitioning were available as /dev/MD. With the advent of 2.6.x kernels, a new type of MD device emerged: partitionable arrays, named under /dev/MD_D. Partitions are indicated by adding p less than n greater than sopers with less than n greater than representing the partition number, e.g., /dev/md/md_gp3. As of Linux kernel mainline version 2.6.28, even non-partitionable arrays can be partitioned, following the same naming convention as partitionable arrays, like /dev/md/md1p2. Since version 3.7 of the Linux kernel mainline, MD now supports trim operations for SSDs in Linear, RAID 0, RAID 1, RAID 5, and RAID 10 configurations. Regarding booting, as MD support resides in the kernel, challenges arise when trying to use MD before the kernel initialization, notably absent in bootloaders like Elilo or Grub Legacy, and with some variations in Grub 2. In such cases, a /boot file system must either operate without MD support or with RAID 1. External metadata, introduced from version 2.6.27 of the Linux kernel and version 3.0 of the mdadm user space utility, enables Linux software RAID to interact with external metadata formats, facilitating the use of firmware or driver-based RAID volumes, known as fake RAID. The supported external metadata formats as of October 2013 are DDF, disk data format, and the volume metadata format utilized by Intel Rapid Storage Technology, RST.